Hey YouTube, welcome back. Message queues. A message queue is a communication mechanism used in distributed systems to exchange messages between different components or services asynchronously. Message queues enable decoupling of components, improving scalability, fault tolerance, and overall system reliability. Let's first talk about why do we need the message queues, and after that we will talk about how the message queues actually work in practice. So first, let's start with why do we need the message queues? And there are several reasons. I would like to focus on four reasons why we need the message queues. The first one, it will be decoupling components. It allows components to communicate without waiting for each other to process the message, improving responsiveness, which is the asynchronous communication. Also, components can operate independently, reducing direct dependencies and making the system more modular, which is loose coupling. The second thing will be scalability. Messages can be distributed across multiple consumers, enabling load balancing and parallel processing. Also, easily scale consumers up or down based on the volume of messages. Number three, we need it for fault tolerance and reliability. Messages are stored in the queue until they are processed, ensuring that no messages are lost if the consumers fails, and also to make sure the messages are persistent. Also, failed mechanism can be retried automatically, increasing the reliability of the system. And lastly, number four, which will be throttling and load shaping. We can control the rate at which messages are processed to prevent overloading consumer, which is the rate limiting. Also act as a buffer to absorb bursts of traffic, allowing consumers to process messages at a steady rate. So let's talk about the key concepts of the message queues, specifically the producer and consumers module. So we will have a producer, and this producer will send the messages to a message queue, and we can find like let's see. Okay, let's say that these are the messages, and the message queue will send the requests to a consumer. And the consumer as well will subscribe. The consumer will subscribe to the message queue. So let's talk about how it works. First, we have the producers and the consumer. The producer and an application or service that sends messages to the message queue, and the consumer an application or service that retrieves the and process messages from the message queue. And we have the message by itself, and it's a direct unit of data sent by a producer and received by a consumer. Messages can contain various types of data, such as text, JSON, or binary. And we have the queue by itself, and this is a queue, which is a data structure that stores messages until they can be processed by the consumers. Queues typically follows the first in, first out principle, but other ordering strategies may also used. Also, we have acknowledgement. So the process by which a consumer inform the message queue that a message has been successfully processed, allowing the queue to remove the message. And there are some things like a dead letter queue, but it's outside of the scope of this video, so we'll not talk about it. So there are multiple types of message queues. There is point to point, and there is publish subscriber, and this is the publish subscriber, which is messages are sent to a topic, and multiplied subscribers can receive processes each message. And it's great in the avid podcasting notifications, etc. There are popular message queue systems like RabbitMQ, Apache Kafka, Amazon SQS, and Google Cloud pops up. So in conclusion, message queues are essential for building scalable, reliability, and decoupled systems. They enable asynchronous communication between components, improve fault tolerance, and allow for flexible scaling to handle varying loads. By leveraging message queues, developers can create robust and efficient distributed applications that can adapt to changing demands and recover gracefully from failures. So that's it for this video, and see you in the future.